Hello and welcome back. Today let's start chapter 5. We're going to move away a little bit from right triangle trig and look more at the identities in fundamental form. So the fundamental identities, you already know them. The reciprocal identities, quotient identities, Pythagorean identities, which we can also write in radical form. So if we want to isolate any of those variables, we can. Just remember when we take the square root, we have the plus or minus. We have the cofunction identities. Remember, that's because it comes from the right triangle, and those two angles would be complementary. And the even and odd identities. So remember, most functions are odd except for cosine and secant, which are even. Okay, so let's evaluate sine of x equals 1/2 when cosine is less than 0, meaning it's negative. So that would put us into the second quadrant, right? So the sine is positive and cosine is negative. And we want to actually use the identity. So we want to refrain from trying to use a right triangle. This is just for practice, and knowing these is really helpful. So we know that the reciprocal of sine is cosecant, so this will just be 2 if sine was equal to 1/2. For cosine, we can use the Pythagorean identity. So we know that sine squared plus cosine squared equals 1. And we could just substitute that in. So 1/2 squared plus cosine squared x equals 1. When we subtract that from 1, we'll get 3/4. And we could take the square root of both sides. So we'll get cosine of x equals plus or minus √3/2. And remember, we said that this function would be in the second quadrant, so this will be negative √3/2. Well, the secant is just the reciprocal of cosine, so we could rewrite that as negative 2/√3, and we want to rationalize the denominator, so we'll write that as negative 2√3/3. So those first 3 right away. Now, for tangent, we can use the quotient identity. So remember, cosine and sine have that relationship. So tangent of x would be sine of x over cosine of x. And we know that the sine of x was 1/2. We know that the cosine was negative √3/2. So we'll get negative 1/√3, and we can rationalize that to negative √3/3. And then cotangent is just the reciprocal, so that'll just be negative √3. Whenever possible, we want to try to factor and simplify these expressions down to one trigonometric term. So looking at A, we can see that both terms have a cosecant. So if I factor out the cosecant, I'll be left with cosine squared minus 1 inside the parentheses. Now, we know that sine squared plus cosine squared equals 1. So if we subtract 1 from both sides, well, this will be equal to negative sine squared. And I could write cosecant as the reciprocal function. So that's 1/sine of x. And when we multiply those, well, we have one of the signs reduce, and we'll be left with negative sine of x. Looking at the next problem, well, we have a lot of things going on. So what I'm going to do is actually change everything into reciprocal identities. So here we have 1/sine of x. I'm going to leave this cosine. I'm going to leave it in terms of sine and cosine. And here, cotangent is cosine of x over sine of x. Well, you can see right away that they both will have a 1/sine of x. So essentially, cosecant factors out. And I'll be left with 1 minus cosine squared of x. And here we see the Pythagorean identity again, and we know that 1 minus cosine squared is equal to sine squared. And then again, one of the signs will reduce, and we'll be left with sine of x. Now, oftentimes we'll have to factor and use our algebraic skills to simplify these. So when we see 1 minus cosine squared, we can also factor that into a difference of squares. And we may not be used to it, but we'll be using that a lot this section, is using our algebra skills with the Pythagorean identities. So we can factor that into 1 plus cosine of x times 1 minus cosine of x. Now looking over here, we have 2 cosecant squared minus 7 cosecant x plus 6. Now this is where you can actually replace the variables if that makes it a little bit easier. And if you want to say a equals cosecant of x, and then factor and then just plug it back in. But we know that this is going to factor in. We have 12 here, and we know if we use factors minus 3 and minus 4, well, we could separate this and factor it pretty easily. Actually, let me write it the other way here. Minus 3a. And then after we factor it, then we could substitute that cosecant back in. So that makes our lives a little bit easier here. So factoring this out, we get 2a minus 3. And you can see we have a minus 2, 2a minus 3. So remember, a was cosecant of x minus 2. And then the second parenthesis will just be 2 times the cosecant of x minus 3. So factor that. Now the next one, we have 2 different things going on. We have a secant and a tangent. So wherever possible, we want to try to make the expression with one trigonometric function. And we know that secant and tangent have a Pythagorean identity. So secant squared is equal to 1 plus the tangent squared. So if I plug that in or substitute that in for secant squared, I can easily rewrite this. So we have tangent squared plus 3 times tangent plus 2. And that's an easy factoring. That's just going to be x plus 1, x plus 2. So this is going to be tangent of x plus 1, tangent of x plus 2. I wrote 1 plus 2. All right, so whenever possible, you can use your algebraic skills there. Okay, the next skill that we're going to work on is find the LCD. So that's really not that hard. Here you have 1 plus sine of theta, 1 minus sine of theta. Well, we know that the LCD would be 1 minus sine squared. So we're going to have to multiply this first parenthesis by 1 minus sine of theta over 1 minus sine of theta. And then multiply the second parenthesis by 1 plus sine of theta. So on the denominator, we'll have 1 minus sine squared of theta. And on the top, we'll have 1 minus, I'll write it out, sine of theta plus 1 plus sine of theta. And you can see that the sine of thetas in the numerator cancel out. And we're left with 2 over 1 minus sine squared. And we know that 1 minus sine squared is cosine squared. And we could rewrite this without a fraction because cosine squared, the reciprocal of cosine squared, would be secant squared. So we could rewrite that as 2 secant squared theta. And it's always preferable to write it without a fraction. So for example 5, it's the same idea. We're trying to simplify this and get it out of fractional form. So when we have this one, well, it's a little bit tricky, but we already use our skills from the previous examples. We're going to rewrite cosine squared. So remember, cosine squared is the same as 1 minus sine of squared. And then we can factor that numerator. So we have 1 plus sine of theta, or sorry, sine of y, not theta, and then 1 minus sine of y over 1 minus sine of y. And you can see right away the 1 minus sine of y is going to cancel the numerator and the denominator, and you'll just be left with 1 plus sine of y. So using all those algebraic skills helps us simplify these expressions. Okay, now we're going to use some substitution. So we're going to substitute x with 5 times the sine of theta, and just be cognizant that we are trying to make sure we're staying within the first quadrant. So all of our angle measures will be between 0 and pi over 2. All right, so when we substitute this in, we get 25 minus 5 times sine of theta squared. So this will equal the square root 25 minus 25 sine squared. And we can factor out that 25, and we can take the square root of it pretty easily. So before I do take the square root, I'm going to make sure that I simplify and substitute first 1 minus sine squared. So we know that 1 minus sine squared is cosine squared. And when we take the square root, right, when we simplify that, it's just a positive value because we're simplifying this. So we're going to have 5 times the cosine of theta. And that makes sense because it had to be in the first quadrant. So simplifying this, remember you don't get plus or minus unless you're solving. Okay, let's look at the last example. Here we have natural logs, and remember we're trying to condense this into a single logarithm, so bringing chapter 3 back. We have natural log of secant theta plus the natural log of cotangent of theta. Remember when you're adding logs, if you're going to combine them, you can multiply them. So inside, so this will be natural log of secant theta times cotangent of theta. Well, that's definitely a good expression, but it's not simplified into one trigonometric function, which we always want to try to do. So what I'm going to do is rewrite secant as 1 over cosine, and then cotangent is cosine over sine. And you can see right away that these cosines will cancel, and we'll be left with 1 over sine. So that's just going to be the natural log of cosecant theta. And just notice that we're trying to keep and maintain those absolute values because we cannot have a negative power inside a logarithm. Well, I hope this lesson was helpful, and I'll see you on class.